Andrea, what are these end parts? Synaptic end knobs, that's right. What kind of cell is this? Multipolar. Good job. You guys had a rough weekend? Okay. I just want to bring it all around full circle. All right, so let's go through what happens first. Some sort of action potential, okay, travels down this neuron, right? What happens when it gets to the end of this neuron? It opens voltage-gated calcium channels. Voltage-gated calcium channels, okay? So calcium comes rushing in. Right? Voltage-gated calcium channels. Calcium comes rushing in. What does calcium do?
Synaptic vesicles.
Right, we have synaptic vesicles here holding neurotransmitter. We have exocytose of these neurotransmitters into the synaptic cleft. What do those neurotransmitters then do? They bind to what?
Receptors.
Receptors. So let's say this is let's say this is an inhibitory event. So I use red. Red means stop, right? Okay, so if this is a inhibitory event, what kind of channels are they linked to? Chlorine channels. So when the neurotransmitter binds, what comes in? Chlorine ions. So we're going to get more negative, right? All right. Now let's say an action potential at the same time comes down this one and this one. Okay? And again, they're going to open calcium channels, right? Voltage-gated calcium channels. Calcium's going to come in. Calcium's going to push those synaptic vesicles towards the end knob. And we're going to have exocytose of a neurotransmitter into the synaptic cleft. Let's say this is an excitatory event. So now we're going to have excitation. So what type of channels are going to be opened? Sodium channels. So when these guys exocytose, they're going to bind to a receptor that is linked to a sodium ion channel. When that happens, sodium channels open. Do we become more positive or more negative? More positive, because sodium is positive. And because we have two, they're going to outnumber that one, right? Okay, so let's say now these guys can add up to that magic number. What is that magic number? Negative 55. So if we can add up to that right here at the axon hillock, all right, then we're going to send an action potential. What does it mean to send an action potential? When I drew this, what is going on? Who's opening? Sodium channels. What kind of sodium channels? Voltage-gated sodium channels are going to open. Voltage-gated sodium channels. All right? The voltage-gated sodium channels are going to open. Sodium is going to rush in, right? We don't trickle in at this point. Yes, like a stampede. We opened a huge amount of doors. All right? Free basketball tickets. Whoever can reach there. All right? So, voltage-gated sodium channels open, then the action potential travels down. When I draw it, I'm drawing these sodium channels opening. That's what that little wiggly line means. Okay? The sodium channel's opening. On your exams, if I ask this, I don't want a wiggly line. I want to make sure you guys understand what's going on. Okay? So what happens when that action potential travels all the way down to this end knob? Right, it's going to cause the opening of voltage-gated calcium channels. All right, and all of the end knobs are going to get the same signal. right? Not just one of them, it's gonna happen to all of them. So calcium's gonna come in. We're going to do what? We're gonna exocytose some sort of neurotransmitter. And let's say this one is inhibitory. It's gonna open what kind of channels? Chlorine channels. So the whole point of activating this neuron was actually to inhibit this neuron. Right? Pretty cool, huh?
So with the neurotransmitters, chlorine and sodium are just the response, are the two responses. So inhibitory, there can be all these different types of neurotransmitters, but they're doing the same thing.
So we talk primarily about sodium and